Welcome to my channel. Today we are stepping into the deepest mysteries of our universe, the world of black holes, explained the Hawking way. So sit back, relax, and let your mind travel beyond the edge of space. Imagine standing on the edge of a place where the universe bends, twists, and stretches a place where time slows, light struggles to escape, and reality itself begins to crumble. Welcome to the world of black holes. Today, I want to take you on a journey, not just through space, but through the boundaries of human understanding. And as you listen, I invite you to imagine that our universe is far stranger and far more beautiful than anything we have yet discovered. In this video, we will dive into the mysterious depths of black holes, not as distant cosmic monsters, but as the keys to understanding the very structure of reality. Black holes are among the most fascinating objects in the cosmos. They are born when the life of a massive star comes to an end. A star many times larger than our sun spends millions of years burning hydrogen into helium, radiating light and heat across the darkness of space. But even stars, with all their brilliance, cannot escape death. When such a star runs out of fuel, it loses the outward pressure that keeps it stable. Gravity, always waiting patiently, begins to pull inward. The star collapses. Its layers fall toward its core with unimaginable force. And if the star is massive enough, no known phenomenon can stop the collapse. The star continues to fall into itself until its mass occupies a volume so small, so dense, that the gravitational force becomes irresistibly strong. A black hole is born. At the center of this collapsed star lies what we call the singularity. It is a place where the density becomes infinite, where our known laws of physics break down. It's a point where space-time curves so steeply that the mathematics begins to fail. Everything we understand about forces, particles, and fields ceases to apply. The singularity is the ultimate reminder that our universe is still full of secrets, and that many of them lie beyond the horizon of our current knowledge. Surrounding the singularity is the event horizon, the boundary of no return. This is not a physical surface. It has no thickness, no texture, no surface to touch. Instead, it is a mathematical boundary in space-time. Once something crosses the event horizon, it cannot come back. Not a star, not a planet, not even light itself. Time and space inside the horizon are warped so intensely that the direction forward in time points inevitably toward the singularity. Crossing the horizon does not feel dramatic. If a human fell into a supermassive black hole, they might not even notice the moment they passed the boundary. But from the outside, something strange happens. To a distant observer, the falling object appears to slow down, dim, and eventually freeze in time, never quite crossing the horizon. The universe would watch you fall forever, but you would fall in a heartbeat. Gravity is the sculptor of these cosmic engines. The gravitational force around a black hole distorts the path of light, creating the beautiful and eerie effect known as gravitational lensing. Light passing near the black hole bends, curves, and wraps around it, producing rings of light that seem to hover like a cosmic halo. This effect allows scientists to photograph the silhouette of a black hole, not by seeing the black hole itself, but by capturing the glowing material swirling around it. It is a window into the invisible. Black holes were once thought to be eternal prisons, swallowing everything and releasing nothing. But I proposed something that challenged this idea, something now called Hawking radiation. According to quantum mechanics, empty space is never truly empty. It bubbles with pairs of particles that appear and disappear in an instant. Near the event horizon, one particle can fall into the black hole, while the other escapes into space. The escaping particle becomes real, carrying energy away from the black hole. Over unimaginable lengths of time, the black hole slowly loses mass. It radiates, it shrinks, and eventually it evaporates. The most powerful objects in the universe are not eternal. Even they fade away. This evaporation process is extremely slow for large black holes, but for smaller ones, it can create bursts of energy that rival entire galaxies. This leads us to a profound puzzle. What happens to information that falls into a black hole? In physics, information cannot be destroyed. If it were, then the universe would lose its ability to determine what happens next. The past would be erased. But black holes swallow information entirely. Or so it seems. This contradiction is known as the black hole information. It has led scientists to propose bold ideas. That information is stored on the event horizon, that black holes are holograms, or that the universe itself is a vast quantum code. In whichever direction the answer lies, it will not only change our understanding of black holes, but our understanding of reality. Let us now imagine falling toward a black hole. As you drift closer, the gravitational pull on your feet would become stronger than the pull on your head. This stretching effect, known as spaghettification, would elongate your body until it is torn apart. But if the black hole was supermassive, millions of times the mass of our sun, the tidal forces at the horizon would be gentler. You might pass the event horizon without harm. You might drift peacefully toward the singularity, watching the universe outside accelerate wildly into the future. In a single moment, billions of years could pass in the cosmos above, while you continue your silent journey inward. Black holes are not isolated. Many of them are surrounded by disks of hot gas swirling at incredible speeds. As matter orbits the black hole, friction and compression heat it to extreme temperatures, producing X-rays and gamma rays. The accretion disks can outshine entire galaxies. Near the poles of some black holes, we see jets of energy traveling at nearly the speed of light, shooting out into space for thousands of light years. These jets are among the most powerful events in the universe. They are a reminder that black holes are not only destroyers, they are also creators, shaping galaxies, igniting star formation, and influencing the structure of cosmic evolution. At the center of almost every large galaxy, including our own Milky Way, lies a supermassive black hole. The one in our galaxy is called Sagittarius A. It is 4 million times the mass of the Sun. Without it, the galaxy would not have formed the way it did. These supermassive black holes act as anchors around which billions of stars orbit. They are the quiet hearts of galaxies, guiding the dance of cosmic matter. Black holes also allow us to test the limits of Einstein's theory of general relativity. According to relativity, gravity is not a force pulling objects together. Instead, it is the curvature of space-time itself. Black holes represent the most extreme curvature, where the geometry becomes so sharp that space-time folds in ways almost unimaginable. When two black holes collide, they send ripples through the universe, known as gravitational waves. These waves stretch and squeeze space as they travel. We detected them for the first time in 2015, confirming Einstein's prediction a century after he made it. Each detection tells a story of black holes merging, spiraling together in a cosmic dance, releasing more energy in a moment than all the stars in the universe combined. The study of black holes has revealed something profound about the universe. At the smallest scales of physics and the largest scales of astronomy are deeply connected. Quantum mechanics governs particles smaller than atoms. General relativity governs stars, galaxies, and the structure of the universe. Black holes are the meeting point of these two theories. They force us to confront the contradictions between them. They compel us to search for a deeper, unified understanding of nature. For decades, I explored the mathematics of black holes, not because they were dark or terrifying, but because they exposed the beauty of the universe's structure. They demonstrated that even in the most extreme environments, the universe remains logical, elegant, and governed by laws that we can uncover. Black holes remind us that human curiosity, when combined with reason and imagination, can illuminate even the darkest corners of the cosmos. Perhaps the most astonishing idea is that black holes might not be the end of the story. Some scientists suggest that the singularity could be a doorway to another universe. In this view, every black hole in our universe might be a point of creation for a new cosmos. This concept echoes the possibility that our own universe began as the result of a singularity. If true, black holes may be the seeds of cosmic rebirth, the engines of universes beyond our own, connecting reality in a vast web of creation. As we look deeper into space with our telescopes and detectors, we will continue to uncover new secrets. Each black hole we study is not simply an object. It is a message from the universe, telling us that there is more to understand, more to question, and more to imagine. In studying black holes, we are also studying ourselves. Our curiosity, our intelligence, our desire to understand our place in the cosmos. The universe is not only stranger than we imagine, it is stranger than we can imagine. Black holes are proof of this. They are the ultimate paradox. Infinitely small, yet infinitely powerful. Perfectly silent, yet violently energetic. Invisible, yet illuminating the deepest truths about the cosmos. As long as we continue to explore them, we will continue to expand the boundaries of human understanding. And so, as we reach the end of this journey, remember that black holes are not just distant phenomena. They are reminders of the wonder of the universe. They challenge us to think beyond the visible, beyond the comfortable, beyond the known. They remind us that our greatest discoveries often lie in the places we fear to look. And perhaps, in understanding black holes, we may one day understand the true nature of reality itself.